Section 8.2, the law of sines. In the previous sections, we looked at if we have a right triangle, how we can solve for the given triangle using SOHCAHTOA, sine opposite over the hypotenuse, cosine adjacent of the hypotenuse, and so on and so forth. That's what trig is mainly for, is to help us to solve for missing sides and angles. And all we have done so far is about we learn how to use the sine, cosine, tangent within a right triangle. Now the question we're gonna answer here today is how to solve an oblique triangle. And that can be done by using what we call law of sines. Law of sines, it's actually a theorem for any triangle, for a triangle ABC, let's say. We always know and keep that in mind. Let's say this is the triangle. The side facing angle B, small b, facing A, small a, facing C, small c. So law of sines says sine A over A equals sine B over B equals sine C over C. Keep in mind that the measure of angle A plus measure of angle B plus measure of angle C is 180 degrees. So these are very important to know because they help us to find missing sides and angles. So to apply the law of sines, there are cases. There are cases we need to be familiar with. And what are these cases? What's the first case? The first case is the SAA case. What does that mean? It means they will give us the side, angle, and angle. So the side is not included between the two angles. And what do I mean by this? Let's look at a triangle like this. They say this is 70 degrees, angle B. This is C, 50 degrees, angle A. B here, C and A. Let's say A is given. So they give us two angles, but the side is not in between. So it didn't give me the side C, which is AB. That would be then angle, side, angle. But this is side, angle, angle. So they give you two angles and then they could give you either A or B. In this case, we need to use the law of sines. So the question would ask us to solve the triangle to the right. So how do I solve such a triangle? Well, law of sines, let me write down law of sines. Sine 70 over B equals sine 50 over 6 sine C over C. But you can't have two variables in one fraction, like in one ratio. So what can I do with C? This is always called alpha, beta, and gamma. So how do I get gamma here? Very easy. It's using the 180, alpha plus beta plus gamma is 180. So gamma here would be 180 minus the other two angles, 70 and 50. So gamma would be 180 minus 120. So gamma is 60. 60 degrees. So we get gamma for this. So gamma here is 60 degrees. So that goes in here. Okay, so now how do we solve for, I've finished solving for the angles. I just need to find the missing sides. So I need to find B and C. So I can take this proportion here to solve for B. Okay, so B sine 50 equals 6 sine 70. Divide both sides by sine 50. That gives us 6 sine 70 over sine 50. So B in this case would be, when you put that in the calculator, make sure the mode is degrees. The mode is degrees. And that gives me 7.36. If there is any unit measure given, make sure you use them. Now I take the next part, which is the last two. So cross multiply, C sine 50 equals 6 sine 60. If you put parentheses like this or not is the same. C equals 6 sine 60 degrees divided by sine 50 degrees. And what do we get for this one? So When you put this on the calculator, depending on which calculator you're using, again, make sure always the degree is the mode is degrees. So put that in the calculator. That gives me about 6.78. Correct up to 2 decimal places. So that's the first case, the side angle case. Side angle case. What's the next case? We have the angle side angle case. Side angle side case. So this means two angles will be given and the side included between them will be also given. Let's look at this. Say we have 40 degrees, call this A, B, C. This angle here 25 degrees, and this is given. Solve the triangle to the right. So how do you solve the triangle to the right? The first thing we need to do is find the missing angle, gamma. So gamma is 180 minus the sum of the other two angles. So gamma is 180 minus 65. Gamma is equal to 115 degrees. So what do we get for this? Sine 40 divided by, call this A, B, over A. Sine 25 over B. Sine gamma, which we just found, 115 degrees over 6. Here I need to solve for A and B. So how do you solve for A? I can't take the first two proportions or fractions because both A and B are missing. So I can take this with the last one. So I can write sine 40 over A. Sine 115 over 6. So then what we do, we cross multiply. A sine 115 equals 6 sine 40 degrees. So A equals 6 sine 40 degrees over sine 115. If we put that in the calculator, I got about 4.26 for A. This is A. I found gamma, and we need one more thing, which is B. So now how do I do the B? You take this and the last one. So sine 25 over B equals sine 115 over 6. Cross multiply. B times sine 115 equals 6 sine 25. So then B equals 6 sine 25 divided by sine 115. And if I put that in the calculator, that gives us about 2.80. A question a student asked me before, can I check this? How do I know I'm on the right track? Or there's no way to really check this. The only thing that can help us to do some checking is we know from geometry that the side facing, remember this, I found this to be 115. The side facing the largest angle should be the longest. So the largest angle is 115. And the side facing to 115 is 6. What about A? We found A. A was 4.26. So if you put on the diagram, about 4.26. And this was about 2.8. So notice the next larger angle is 40. The side facing to it is 4.26. And the smallest angle is 25. That's facing 2.8, which makes sense. See, the smallest angle is facing the shortest side. The largest angle is facing the longest side. So that gives you kind of an idea like, okay, at least I was probably on the right track. The next case, I'm going to write it with the rainbow color. It's called the SSA ambiguous case. We're going to see SSS in the next section. So this case is a unique case. There's a lot of work involved in this one. Not straightforward. That's why we need to pay attention to it. This is when they give you two sides, not two angles, two sides, and non-included angle. So angle is not inside. It's not in between the two sides. So what do we do in this case? Watch the procedure, how we do it. This will create four cases that can happen. So let's say they give me angle A, which I'm going to call it alpha. They will give me B, so I'm going to put a check mark, means those are given, and call this point C. And we don't know where B actually is. Could be anywhere. So they will give us, alpha will be given, B will be given, and A will be given, because it's two sides and non-included angle. What is A? A is supposed to be this, this side, but we're not going to draw it for now. No drawing for now. The procedure is always drop a height down on this side. This is H. And find what the height is. If you do sine alpha in the triangle, it's the opposite over the hypotenuse. So the height can always be calculated using B times sine alpha. That's the height. So the first case that we have, if you calculate the height and you find out that A, so if A is less than the height, so A less than the height means like, could be like this, right? So that's A in this case. So what do you get? We get no triangle. So we can't solve the triangle. And then you stop there. There's no solution. You can't do anything about it. So that's the first case. The next case, which is an easy case, what about if happened that A equals H? If A equals H, means A is exactly there. In this case, B is here. Then we get one triangle, one right triangle specifically. One right triangle. That's the second case. What about the next case? If A is bigger than or equal to B, it just happened that they give it to you, automatically you have one triangle. Since A and B are given, then you can look at it as a first case. Say, okay, A is bigger than or equal to B, then one triangle. Then if you have one triangle, what you have to do is solve using law of sines. In the right triangle, you can use SOHCAHTOA, Pythagorean theorem, whatever you like. There's more options other than law of sines. And the fourth case, that's the one that requires more work. If we find the H and happen that we found that H less than A and A less than B, then there are two distinct triangles. There are two distinct triangles. And what are these? How can we get two distinct triangles? Let me draw the diagram again. So this was point C. This is the height. A, alpha, and B. So if that's the case, two triangles can come out of this. The first triangle is going to be this way. So A can be inside or A can be outside, like that. That's why we have two triangles. Usually I call this B1 and this is B2. So I have to solve two triangles at the same time. So if this is B1, that's B, that's C. I call this gamma 1 and this is small c1. So what we do, we take in triangle A, B1, C. And this is beta, called beta 1. We use law of sines always to find beta 1. And when we find beta 1, then the way it works is you're going to be solving sine, let's say beta 1 equals some number. Then beta 1 is sine inverse of that number. Okay? When you put that in the calculus, it's going to give you an answer. Not usually, sine is always positive from 0 to 180. And that's because beta is one of the interior angles of the triangle, is going to be somewhere from 0 to 180. Right? So beta 1, when you find beta 1, let's say beta 1 was this angle here. Sine is positive in the first two quadrants. So to find beta 2, which is going to be this one, that's beta 2. So beta 1 is the small angle, beta 2 is that angle. So I'm going to put beta 1 here to see it, beta 2. Then you can find beta 2 right away, always 180 minus beta 1, because this is beta 1. So we're going to find beta 2 always 180 minus beta 1. And what is beta 2? This is beta 2. Now notice in the shaded triangle here, the triangle I'm shading now, we found beta 1 and we are given alpha. Then you can find gamma 1 and you are given A, you are given B. Then you can find C1 using law of sines. Then you are done solving the yellow triangle. Now we have to solve the other triangle. The other triangle to solve is the big triangle ACB2. ACB2. So in triangle AB, ACB2. ACB2. So we have alpha, we solve for beta 2 and B. Beta 2 is done. Alpha is given. A is given. B is given. So we can find gamma. Gamma is going to be the big angle here. This is gamma. So you can find gamma by doing 180 minus the other angles. Alpha and beta 2. Notice we have 6 elements of the triangle. I call them elements. A, B, C, alpha, beta, gamma. That's when they say solve for the triangle, means we need to find all of them. Based on what we have so far, we got gamma, alpha was given, we found beta. A is given, B given, only C left. Then use law of sines to solve for C, or to find C. So that's the procedure for this ambiguous case. Okay, that's the procedure for the ambiguous case. So let's look at some examples on this. Just so you know, as a note, let me write it. In the SSA case, we first determine, as soon as you notice, oh, it's an SSA case, let me first determine the number of triangles. Do not start using law of sines. We need to find the number of triangles, and based on that we can see what we need to do. So we first determine the number of triangles and then solve the triangle. Let's look at an example. Given alpha 41 degrees, A 3.3, B 5.4. Solve the triangle. First thing, as I said, A here, A is given alpha 41 degrees, B is given 5.4, I don't know what that is, C, and keep in mind A is also given. The first step, always drop a height down this way. This is H. As I said before, is A bigger than or equal to B? No. So that third case that I wrote earlier, it doesn't work out. So we must find H. So we told you H here, based on this, it's B sine alpha. So that's 5.4 times sine 41 degrees. So H would be about 3.54. Okay, now we say, is A less than H? Yeah, note that A is less than H, so no triangle. That was the first case. Then it's done. No triangle can be formed, so we can't solve for it. Another example, given gamma equals 125 degrees, B is 5.7, C is 8.6. Solve the triangle. Solve the triangle. So how do we solve a triangle like this? How do I know it's SSA? Well, if you draw the triangle and label it, you can see they give us two sides and not the included angle. So here what we are given, let's say, I drew the triangle. Usually we don't draw this because we know it's a SSA case. So here what they give us, the 125, that's C, angle C, okay? B is this side here, 5.7. This is A, because B has to be opposite, so B is here. So what we do, this is This is the initial side, right? This is the initial side. First thing, we will try to find out which case is it. Remember the first one earlier was, is A bigger than or equal to B? In this case, this side, which is the C side given, that's like A now, based on the other stuff. Is A bigger than or equal to B? Well, A here is C. Remember, A is C. Is A bigger than or equal to B? Yes. A, which means C. C is bigger than B, right, based on this. So, one triangle. Which case is this? That's the third case. If you look back at the cases, that's the third case. This means the side will reach B. So this will reach all the way. So this is now alpha, beta, and we need to solve for the triangle. Notice I can't find the angle right away from 180 because two angles are missing. So the only option I have is law of sines. So sine alpha over, this is A, equals sine beta over 7 equals sine 125 over 8.6. With this one, cross multiply 8.6 sine beta 5.7 sine 125. So sine beta now we're gonna put this as sine is beta equals sine inverse of all this quantity and put that in the calculator. That gives us 32.9 degrees. As soon as I found beta, what we do? We can find alpha. So I can say 180 minus, so alpha is 180 minus beta plus gamma. Beta, we just found beta, 32.9. And the other one was given 125. So alpha, if you calculate it, is 22.1 degrees. So I found alpha, beta, gamma, and B and C. The only thing left is A. So I'm going to go back to law of sines. Law of sines, sine alpha over A equals sine 8.6 over, sine 125, because that was given, over 8.6. Cross multiply. A times sine 125 equals 8.6 sine 22.1. So A equals 8.6 sine 22.1 divided by sine 125. So A becomes, I got 3.9. So we solved for all the elements they ask us to solve within that triangle. So we can look at now a different example. Given alpha 56.3 degrees, B is 8.3, A is 7.6. Solve for the triangle. Notice here what we have is that we are given two sides and non-include angles. So that's SSA case. Always the first thing. The A is given. This is 56.3 degrees. That's alpha. B is given 8.3. Is A bigger than or equal to B? No, it's not. So the third case does not work. Now we must find the height. So if you drop a height down, the height, we said it's B sine alpha here. So the height is 8.3 sine 56.3 degrees. If you put that in the calculator, that gives about 6.9. Notice H, note that H is less than A and A is less than B. So that gives us two triangles, two distinct triangles. Case. Now we are going to draw a diagram for that. A is here, 56.3 degrees. This is B, was 8.3, C, and this is the height, H. And remember we said there are two cases. One case is going to go inside, that's the B1 I call it, and that's going to be like let's say beta 1 and beta 2. This is gamma 1, this is A, which is given, A is given 7.6. So first I start working in this triangle. So in triangle A, B1, C, what do we have? We need to find beta. So what do we do? Sine 56.3 over 7.6 equals sine beta 1 over 8.3. Cross multiply 7.6 sine beta 1 equals 8.3 sine 56.3. So then sine beta 1 equals 8.3 sine 56.3 divided by 7.6. So I need to find beta 1. Beta 1 is sine inverse of all this quantity, 8.3 sine 56.3 divided by 7.6. If we put this into the calculator, let's see what that's going to give us. Again, make sure the mode is degrees. So 8.3 sine 56.3 and divide that by 7.6. So notice it gave me 65.31. If you do 180 minus that, so 180 minus 65.31, that's the 114.69. And you might say, wait, but that's beta 1 is 65. The calculator gave me 65. If you look at the diagram, the beta 1 is the obtuse angle. See, you see this angle here. So the other angle that I found, this was beta 2. This was beta 2. What is beta 2? This is beta 2. This is beta 2. So this is the 65.31. Okay, so I found beta 1. We are given alpha. Now we can find gamma 1. Then gamma 1 equals 180 minus the alpha plus beta 1. 180 minus alpha was 56.3. Gamma 1, 114.69. What is that going to give us? 180 minus 56.3 minus 114.69. It's about 9.01. So it's about 9 degrees. If you want to put 9.01, that's fine too. So we found all the angles are done. All the angles are done. The only thing left to find, we have A, B. We need to find C. So we can say sine gamma 1 over C equals sine 56.3 over A. A was 7.6. Now gamma 1 is the one we just found. So we can substitute it here, 9.01. So C sine 56.3 equals 7.6 sine 9.01. So C is 7.6 sine 9.01 divided by sine 56.3. So C is about 1.4. So I solved for the first triangle. Now we're going to solve for the second triangle. So you're going to go back and solve for AC beta, not beta 2. That's B2. B2. This is angle beta 2. So in triangle AC B2. In triangle AB AC B2. AC B2. What do we have? We have we need to find the big gamma. So this is the gamma here. We already have beta 2, 56.31. So gamma is 180 minus the sum of 56.3 plus 65.31. So gamma would be if we subtract them, that's about 58.39. Let's say 4. So that's gamma. So the three angles are done. We found them. All we need to find is the big C. So sine this gamma that we just found, 58.4, divided by C equals sine 56.3 degrees over 7.6. C sine 56.3 equals 7.6 sine 58.4. So C equals 7.6 sine 58.4 over sine 56.3. So C is about 7.8. So that's the case where we have two triangles. That's an important case. It's called the ambiguous case. In the SSA ambiguous case, there's a lot of work involved, especially when you have two triangles, as you could see. The next thing is an application to how do we use those trigonometric rules that we learned today, like law of sines. What can be an application? So I'm just gonna call it application, okay, to the law of sines. So let's say sometimes they give you like either talk about a building or a mountain, like how tall is the mountain, how high is this building. So let's say we have a building with height h, and the angle we call the angle of elevation here, say it's 40 degrees. And if we move 100 meters this way, 100 meters this way, and you connect this to this angle is, let's say, 56 degrees, 90 degrees. What's the height? Find the height of the building. So they give, that's all the information they give us. Let's call this triangle ABC. This point D here. So this is B here. This is how I'm gonna think about it. I'm gonna first say, okay, I'm gonna look in triangle ABC. If I use sine 40 degrees or sine A is the opposite over the hypotenuse. So if I want to find the height, it's gonna be B times sine A. We know sine A is 40. But to be able to solve for H now, I need to find B, calculate B. So how am I gonna calculate B? Well, the first thing is to calculate B, I'm gonna look in this triangle here. In this triangle, this is given on this side 56. If you do 180 minus 56, that gives us 124 degrees. Okay, why did I find this? Well, I found this because I'm gonna use law of sines in that triangle. So in triangle ADC, I can use law of sines, sine 124 to help me find B, over B equals sine, see, like if I use sine 40, this side is not given, I don't know. So I have to use this side on here, let's call it like gamma. That angle, sine gamma over 100. So to find B, I need gamma. Gamma not difficult to find. How do you find gamma? Gamma is 180 minus the sum of the other two angles, the 40 and 124. So if we do the work, that's a 16 degrees. So I can replace the gamma with 16 degrees here. And now we're gonna solve. So B times sine 16 degrees equals 100 sine 124. So B equals 100 times sine 124 divided by sine 16 degrees. And B in this case is about 300.77. 300.77. Don't forget the unit that measures meters. So now I can substitute this in here to find H. So H is 300.77 times sine 40 degrees. So then H is about 193.33 meters. And that's what we're looking for. The height of the building is 193.33 meters. See, that's an application to the law of sines. So law of sines is a very powerful tool to help us solve triangles. And in real life situation, I showed you here how we use it to find the height of the building, without actually measuring what the height. Like if we have no access to measure the height, but I do know these two angles and the distance from A to D, I'll be able to find exactly the height of the building.